Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In acid-catalyzed esterification, a carboxylic acid reacts with an alcohol to form an ester and water. The mechanism involves nucleophilic addition of the alcohol oxygen to the carbonyl carbon, followed by proton transfers and loss of water. The key isotope labeling question here is, which oxygen is lost as water? Moving on to the next step. Identify the reactants. The carboxylic acid is benzoic acid, PHC, is equal to O, and the alcohol is isotopically labeled methanol, CH3O18H, where the oxygen in methanol is the heavy isotope O18. Moving on to the next step. Determine the mechanism of esterification under acid catalysis, Fischer esterification. The mechanism proceeds as follows. The carbonyl oxygen of the carboxylic acid is protonated, activating the carbonyl. The O18 labeled oxygen of methanol attacks the carbonyl carbon nucleophilically. A tetrahedral intermediate forms with both O from the original acid and O18HCH3 attached to the carbonyl carbon. Proton transfers occur. The O group originally from the carboxylic acid is protonated and leaves as H2O, unlabeled water. And for the final step, identify the product. After loss of the unlabeled O as H2O from the carboxylic acid portion, the ester formed is PHC is equal to O18CH3. The O18 label from the methanol is retained in the ester linkage, the single bond oxygen connecting carbonyl carbon to CH3. Identify the water formed. The water produced is H2O, not H2O18, because the O lost comes from the carboxylic acid, not from the labeled methanol. This reaction is a direct esterification, Fischer esterification, between a carboxylic acid and an alcohol, which is correctly named an esterification reaction. Why other options fail? Option A shows the same product PHC is equal to O18CH3 but labels the reaction as transesterification. Transesterification involves an ester reacting with an alcohol, not a carboxylic acid with an alcohol. This label is incorrect. Option C shows PHC is equal to O18CH3 but labels it as saponification. Saponification is base-catalyzed hydrolysis of an ester, which is completely different from this reaction. Incorrect label. Option D shows PHC is equal to OCH3 without O18 label in the ester bond. This is incorrect because the O18 from methanol should appear in the ester product, not be lost. Also labeled as hydrolysis, which is incorrect for a synthesis reaction. Option B correctly identifies both the product, PHC, is equal to O18CH3, with O18 retained in the ester, and the reaction type, esterification reaction. Therefore, the correct answer is B. Therefore, the correct answer is option B.